The first thing I'm going to do is share my screen. So we are in perimeters, areas, percentage, and grade, and thank you for that. This is the 105B ILM. I think it's 210105B is actually what it is. And if you have that, I would appreciate if you grab that particular ILM, pull it out, and we are going to start there. Last week, we completed all of our fractions. We just started on a perimeter. I think the very last question in your assignment was a big perimeter question. And that was, you had to add everything together, minus off all the doors to get your answer. And so we're just going to continue more with perimeters, and we're going to get into areas here pretty quick. So let me just scroll down here onto this ILM. So the objectives for this ILM, and remember, I said this before, if you want to know what to study out of any particular ILM, it's the objectives that you study, right? If you want to go into an ILM and say, I don't know what I need to know in this one, you look at the objectives. The objectives are going to give you what you need to know, right? So this one, today at least, we're going to identify concepts with working with formulas. We're going to apply formulas for calculating perimeters, rectangles, triangles, circles, and apply formulas for calculating the surface area of solids, tanks, and cylinders. And I should also add here hemispherical tanks. We're also going to do a little bit on that as well. Surface area only for those particular things. Okay. Now, objective number 4 and number 5, I want to cover on Wednesday. So I want to get through the first 3 today, and then you will have an assignment. And then next Wednesday, or excuse me, this Wednesday, we're going to cover the other 2 objectives on there. Any questions so far? Good? All right. Okay. So I'm not going to go through all of that, but we're going to go to page 2. Oh, that's not page 2. We're going to go down here to page 2. Let's see. Do I have page 2 in here? Maybe I don't. I don't have page 2 in here. But that's okay. We don't need page 2 in here, because I can just start over here. So what I'm going to do is, as you can see, we're going to start with the area of say a rectangle. As you can see, the area of a rectangle is simply length times width. And before we continue, I want to start talking about these formula triangles. You see this triangle right here? This is a formula triangle, and it only is there for ease of use for you. So for this triangle, if we want to figure out anything within this triangle, you will always be given 2 variables, and you will have to figure out the third one. Now, on these formula triangles, anyone. So if we wanted to figure out the area right here, all I have to do is put the area over here, cross it out, and do the operation that's in the triangle. And this going across means times. So length times width is equal to the area. And this is how these formula triangles work. We simply take anything out of it that we want. So if we wanted to find out what the length is, we just put it outside and we take the area and we divide. So this line going up and down is a dividing line. We take the area and divide it by the width. That would equal my length. So any one of these formula triangles, we can solve for an unknown by simply taking it out of the triangle, making it the equals, and do the operation that's left. Is there any questions on that? Okay, so for example then, let's do a couple of examples. So if I had an area of, well, I need a pen for this. If I had an area of 144 inches squared, that's my area. So the area equals 144 inches squared. And I had a width of 12 inches. What is my length? So this is the question mark, is what is the length of that? So I want the length here, so I'm going to take that out and put it over here. So I'm going to take my area. So it says 144 inches squared divided by 12 inches, because I take the area up here, divided by 12, this is divide, and that would equal my length, which is 12 inches. So we simply take out what we need out of the triangle, and yes, thank you, Bay. And that is that. Okay, let me just do another possible example here. But before I continue with that, I want to make the mention that 12 inches by 12 inches is equal to 144 inches squared. So that is 1 foot times 1 foot, which is equal to 1 foot squared. So I can always say that there's 144 inches squared in 1 square foot. And I think we talked about that last week. And just this number right here, this little statement right here is something that you need to memorize. It's one of those things that you should know that there's 144 square inches in a square foot. Is there any questions on the rectangle and how to solve for area of a rectangle? The perimeter of a rectangle is a little different, right? Ooh, what did I just do there? That was super weird. Perimeter of a rectangle, and perimeter, if I go back into what perimeter means basically around. It is the outside distance around any object. So perimeter or circumference. So perimeter is just adding the width plus the length plus the width plus the length. Hence this formula triangle right there, length times 2 plus width times 2. It's pretty straightforward stuff. Is there any questions on how to calculate the perimeter of a rectangle? No? Okay. Excellent. I want to now go into a circle. Now, this is really important for us. As plumbers and gas fitters, we talk about pipe a lot. This is really important that circumference, the circumference of a circle right here, that is basically the perimeter. Okay, it's just a different word that we're using for that. So the perimeter of a circle is the circumference. As you can see, we have a formula triangle right here. And so anytime we want to do that, we're going to use pi. And pi is going to be 3.1416. I want you to use those digits or hit the pi button on your calculator. One or the other. That gives us a little more accuracy when we're doing all of these, okay? So use those 3.1416 or the pi button on your calculator to do any calculation. Now, a diameter of the circle is the distance across. Okay, it is very much the distance across the circle itself or the cylinder or whatever it is, and the radius is half of the diameter. That's pretty straightforward. Yes, I don't think that is new information to anybody. So let's do, I shouldn't have, let's do a couple of questions on circumference and area of a circle. So if I told you that I had a diameter of 34 millimeters, I want you to find out the circumference of that circle. Pretty easy stuff, I think. The circumference is what, 106.8 millimeters? Yes? Yes. Yes, thank you, Alex. Okay, that's pretty easy stuff. That's not too difficult, I would say. So let me ask you another question pertaining to this. So say I had a circumference is equal to, let's put 800 millimeters. What is my radius? So if I was to do that, there's my formula triangle. I'll take my circumference, 800 mils, and divide it by pi. That should equal my diameter. And so the diameter is equal to 254.6 millimeters. Is that the answer I was looking for? No, I'm looking for the radius. So we must divide that by 2. Thank you, Dallas. It's 127.32 is equal to my radius. So we really have to pay attention to some of the terminology that's going to be described in some of these questions. Okay, so let's get into a little more on areas of a circle. Okay, so now we're going to do the area of a circle, and the formula for that, if I was to write it out, it's pi r squared is equal to the area. So you see this formula triangle up here, it says pi r squared and area. So there's the formula written out. Now, I want you to get into the habit of writing the formula down before you do your question. That way you can see what you have and then write out your variables that you have and then insert them into the formula. For example, I have a circle that has a diameter of 132 millimeters. I want you to find the area of that in square millimeters. Already got the answer. Where else to share it? So I guess I should have said you should have your calculator handy. This is math class. I guess it was an assumption. So what we do is pi r squared is my formula. In this particular one, my radius is half as much. So my radius has to be 66 millimeters, yes? So the area is equal to 3.1416 multiplied by 66 squared. So the area, if I do that calculation, is 13684. Whoa. I am not looking where I'm drawing or writing. Let me just do that again. Millimeters squared. So here's the thing about area. Area, if you see the word area anywhere in any question, if you see the word area, you are always going to have feet squared, inches squared, millimeters squared, meters squared. You're always going to have squared something. And now what's super important around areas and moving forward in areas is that, here, let me just put that up here. Your increments of measure must be the same. I can't multiply feet and inches together. I can't multiply millimeters and meters together. I can't multiply centimeters and meters together. So you understand that we cannot multiply dissimilar increments of measure. We must always have them the same before we multiply or divide any of these numbers together. Okay, so that's super important. You need to make sure that you have that. Now, everybody can see. Oh, yes, please do.
Did you use pi or did you insert 3.14 when you
I used pi on my calculator. So if we're off, Kristen, by a tenth or a hundredth of a millimeter squared, we're going to call our answers good. Okay.
Can you just tell me how to use pi with my calculator quick?
There is a button called EXP at the very bottom. It's 2 in or no, 3 in from the right or the left.
Yep.
So hit that button and pi will show up.
So say I'm going 6 times pi, I can just go 6 and then the exponent button and then that will do it.
Yes, so you have to hit the times though. You have to hit the times button, yes. Okay. So you can go 66, hit the square button, and then say times and hit the pi button and hit the equal sign. Does that make sense?
Yes.
Okay, excellent. But thank you for that. Thank you for clearing that out. So before I move on to some other avenues in here, guess what? It's 10 to 9. It doesn't take long for us to go through an hour. So take a 10-minute break, come back at 9 o'clock, and we'll continue on with some more of this stuff. Okay. Stretch your legs, get some refreshments, some water, whatever it is, and be right back. I'm going to pause the recording as well, so we don't have to do it over a break. Okay, I'm going to share my screen to where we left off here. So we talked about a circle, we talked about area of a circle. There is one question I want to do with you first before I continue on. So using your, let's see, using this triangle where the area is equal to the pi times the radius squared, I'm going to say the OD of a pipe. Does everybody know what OD means? OD means outside diameter. Okay, OD means outside diameter. ID is inside diameter. So OD of a pipe is 6.25 inches. The wall thickness is 0.25 of an inch. What is the ID? And if you have your answer, just shout it out or whatever, put it in the chat. I don't care. Just
5.75.
that is correct. So 5.75. Now, how the heck did they get that? So let me draw a piece of pipe for you. You have one circle and you have two. So this is the inside diameter. This is the outside diameter. I know it's not very good. It's not a very good drawing. I apologize for that. So the outside diameter was 6.25 inches, yes? Well, and I said that the wall thickness was 0.25. How many wall thicknesses do we have on a piece of pipe? We have two wall thicknesses. So right there and right there. We have one there and one there. So we have to take two wall thicknesses off of our outside diameter to get our inside diameter. So that's going to be 6.25 inches minus 0.5 inches, which is equal to 5.75 inches is my inside diameter. Okay, so that's also really important to remember for us plumbers, gas fitters, pipe fitters, steam fitters, sprinkler fitters, whatever it is you're doing, that a pipe, if we're looking at it, inside diameter minus outside diameter, we have two wall thicknesses there. Okay, just be aware of that because this will probably come up again for sure. So thank you for that. I'm going to move that one over. And we're going to talk about this one right here. We're going to talk about triangles. So to find the perimeter of a triangle, as you can see here, is we simply add all of the outside lines together. Yes? Now, to find a perimeter of a triangle, they will give you all of the lengths and you will just have to add them together. Now, they can give you some different lengths. For example, I could say find the perimeter of a triangle with one length equals 25 mils. Another equals 0.25 meters. And another is equal to 0.5 centimeters. What is my perimeter of my triangle in meters? So take a minute, find the perimeter of that triangle in meters. So there is a couple of things that you really need to know in this, don't you? You need to know that 1 meter has 1,000 millimeters. you need to know that 1 meter has 100 centimeters to solve for this. So to convert 25 millimeters into meters, we simply divide by 1,000 millimeters per meter. I'm not sure yet, John. I haven't done the math. I'm pulling numbers right out of my hat here. So that's 0.025 meters. So there we go. We go 0.025 meters plus 0.25 meters plus, and now I got to convert the 0.5 centimeters divided by 100 centimeters in a meter to get 0.05 meters. And then we're going to add, and we add those together. And John, I don't know where you got the 0 from, but the answer is 0.325 meters is the perimeter of that triangle. Okay. So again, similar measurements or dissimilar measurements that you have to convert and then to get. Sure, John, half a mark anytime. So that's another one where we have to convert these numbers. Now, the area of a triangle, so you can see the formula is right here. Here's the area of a triangle. So it says base times height divide by 2. So we divide by 2 because a right angle triangle is really just a square, length times width, divide by 2. Now this only works if you are using a right angle triangle. Does everybody know what I mean when I say right angle triangle? When I say right angle triangle, this has to have a 90-degree angle in it. Anytime I say right angle triangle, it has to have a 90-degree angle. We cannot do the area of the lower one for the perimeter one. We can't do that, okay? So let's do a question on area of a right angle triangle. So say if I had a base and that equaled, let's do something really crazy here. 5 5/8 inches. And I had a height of 1 foot 2.5 inches. What is my area? So now we have to do some work. And I want my answer in feet squared. So you have a little more work to do. Do you guys concur? Yes.
Yes.
So that's a lot of work for one little question. And this is math in a nutshell. Some of the questions that I'm going to ask you take a little bit of time to put things together, to get it in the right increments of measure, and then to solve for the answer. So I'll give you a minute to catch up on there.
Do you think you could scroll down just a smidge for a second?
Yeah. Like which way?
Down. I just want to see this question.
Okay.
That's 0.5 centimeters, right?
Yes.
Wouldn't that go 0.005 meters?
Oh, you are so correct. See, where were you before here?
I was trying to figure out this question.
Okay. Kristen, you need to be on top of me earlier. I go too fast. So.
I was trying to figure out where my mistake was. I was trying to go through it
Oh
all.
no, you see, I go too fast and I make mistakes. And I guess that's a good lesson for all of us. Thank you for that, though. That's a good question. That's good. I think I got the area of the triangle correct, though.
Well, it would change the answer up top by a little bit.
Yeah. Okay. Thank you for that. Okay, we're all there. Everybody's there. Okay, so that's kind of the area of a triangle. And remember, area is always in squares of something. So I'm going to write a new question. Just, I want to see if you are paying attention here. Here's a new question. How many square feet are there in 2,044 inches squared? Shout it out if you have it.
14.194.
Yeah. So you had to know that there is how many square inches in a square foot? 144 inches squared per square foot. And as you can see, when we divide these out, the inches squared get canceled out, and that equals 14 point, Alex, what did you say?
194.
194 feet squared. So herein again lies the conundrum of what increments of measure should we convert to? So always, I would like you to convert to the bigger number. I want you to convert everything into meters if you can, or feet if you can. So these are the two that I want you to convert everything into, if you can. Now, some of the answers, as you're doing some of these questions, are going to ask you for inches squared or millimeters squared. So sometimes the answer is going to give you a clue on how you do what you need to do. All right, we're really cruising along. And now it brings us to cylinders. Cylinders are basically pipe for us. So cylindrical tanks can be very big. They could be small, they could be classified as a pipe, they could be anything to us in that regard. Now, I'm not going to go over the volume one with you, not yet. This is not yet. We want to know the surface area one down here. So we're talking about areas. And the surface area of a pipe is maybe I need to insulate something. So that's what we go with surface area of a pipe. So I'm going to start off by giving you a question. I'm going to say I have a pipe, okay, totally enclosed. When I mean totally enclosed, I mean it has a top and a bottom, and it's fully enclosed, okay? So totally enclosed. So we know the area of a circle. We know the area of a circle is pi r squared, and that is the area of a circle. When we say a totally enclosed tank, how many circles then do we have? We have 1, 2. So what we do is we go 2 pi r squared for a totally enclosed tank, and that is for the top and the bottom. And then we add the shell to it, and the shell's formula is pi times the diameter times the height. So we take the top and the bottom, and we add the shell to it. And that's really how, or that is the formula for a totally enclosed cylindrical tank. And now let's give you some variables. I'm going to say this tank has a diameter of 5 feet, and it has a height of 20 feet. I want you to calculate the surface area of this totally enclosed tank. So I write my variables down. Here's my radius. My radius is 2.5 feet. And I could simply plug in my numbers into the formula. So that's going to be 2 times 3.1416 multiplied by 2.5 squared. And that's going to be the top and bottom. And then we add 3.1416 multiplied by the diameter, multiplied by the height. And we add these two together. Let me do this on my calculator. You get us somewhere close to that. Do I have any questions at all? Is there any questions that you want to ask me on surface area of a cylinder? I'm going to do another one here in a minute. Yeah. Okay, here's the next question. I want you to calculate the surface area of an open top cylinder with a height of 15 feet and a diameter of 8 inches. Now, I always start with my formula. So this is an open top cylinder. The formula for an open top surface area of a cylinder is pi r squared plus pi dh is surface area of an open top cylinder. I'm going to rewrite my variables here. My height is equal to 15 feet. My diameter is equal to 0.666 feet. So I converted my diameter into feet. And then my radius is half of my diameter. Now I have the variables. I have my formula. I will write out my numbers. That is the area of the bottom. And now for my shell. Add these two together. And you should have come up pretty closely to 31.7 feet squared. Does everybody concur with this? Christian, is that right? Just want to check. Yeah, okay. Not too bad, huh? A little bit of math going on now. So I just want to reinforce, I want you to get into the habit of writing your variables down. I want you to get in the habit of writing your formula out and then doing the math. So that way everything is in front of you. It makes it harder to miss something if you have it written out. So that's just a way of I do it. I would like you to do it. I'm not forcing you, but this is a way that I know works. It makes you successful. If you write out your variables, write out your formula, insert everything in. Questions? Questions? No questions. Okay, we're moving on. I have in the picture now a hemispherically ended tank. And I'm not being concerned about the volume, not as yet. I just want the surface area of a hemispherically ended tank. You may not have this in your book per se. Might not be in this one, it might be in the volumes and capacities book. So right here is our formula for the surface area of a hemispherically ended tank. And I'm going to rewrite that formula just up here. So it says take the overall length, multiply that by the diameter, multiply it by pi. So one of the ways you can remember this is it's old pi. I like pi. I mean, I don't like old pi because it's probably not great, but there you go. So there is the formula for surface area of a hemispherical tank. So I'm going to give you some variables here. I'm going to say my overall length of this tank is 15 feet. I'm going to say my radius is 2.5 feet. I want you to solve for the surface area of this tank. Yeah, there's a cat right in the camera. Nice one, Christian. My old cat sleeps all day. He doesn't do anything. He sleeps and then he eats and then he sleeps. He doesn't do nothing. And he poops in a box in a hallway. That's, you know, that's what cats do. So I'm going to put my other variable here. I can see I have a diameter, so my diameter has to be 5 feet. It's double the radius. So I simply write it out, 15 multiplied by 5 multiplied by 3.1416. What did you guys get? What is your answer? $231? Close? Yes? No?
I got 235.6.
Yeah, that's what I got.
235? Sorry,
I
I'm
got
just
as well.
guessing here. 235.6 feet squared. It's super important, and it's going to be more important than you realize coming up, that our increments of measure have to be behind our number. You have to have your increment of measure behind your number, all right? That is super important, especially when we get into densities and relative densities and volumes and capacities. Because you know what, if you're writing out a note to your apprentice to go to the wholesaler and you say, pick up some 1/2-inch copper pipe, but you failed to put in 1/2 inch, pick up some copper pipe, 10 lengths, and he comes back with 3/4, gosh, that's not great, right? You need to write down all of the information that you need, right? It's a way of conveying what you want to say. Any questions? Any questions so far? No? You guys are awesome. Let's have a look at a cube. You're doing good. Everybody's doing really good. I'm pretty happy so far. I mean, I don't know how you're doing, but I'm still happy. Look at the surface area of a cube here. Surface area of a cube. As you can see, this is the formula. It's pretty long, this formula, right? Because as you know, there's 1, 2, 3. Over here, there's 4. On the back side is 5. On the bottom, there's six sides. There is 6 sides. So there's 6 sides to a cube, right? So hence we have the length times width times 2. There's width times height times 2, and length times height times 2, making 6 sides. So I'm going to ask you a question on this. What is the surface area of a totally So what is the surface area of a totally enclosed box with sides of 1.5 meters? Totally enclosed box. Anybody got an answer so far? Sometimes these pauses are tough to take for me. I don't like empty space. I want to fill it up. Sydney, you're sharing a calculator with somebody? Looks like you're passing your calculator to somebody.
My battery died, so I can only use it with my light, and my light's not close enough, so the solar part will work, so I need to get a new battery.
Oh, okay. Yeah, or just move closer to the light or turn on a lamp or something. Yeah. Okay, what's the answer? Anybody?
13 point.
13.5 what?
Meters
Cube.
Meters squared. We're talking about an area, not a volume. Area is always in squared something. So I'm going to show you a quick way of doing this. So if I said the sides are 1.5 meters, it's basically a perfect cube. It's equal sided. So I can go 1.5 times 1.5 times 6. Six sides. Yes, that was easy. Did everybody do the length times width times 2 plus length times? Yeah. So yeah. So this is just an easier way if all the sides are equal. Right? 6-sided. That's all we're doing is surface area. Now, I want to know the area of the same box, but it has an open top. So open top. So what is the answer to that? Shout it out if you have it.
0.25 meters squared.
So we only have 5 sides. So there's a 5, yes. So it's 11.25 meters squared. Because there's only 5 sides on an open top box. Okay, we don't need the 6th one. Now, in this formula, what would happen is we would only have 1 here. So this would be gone on an open top box, right? You would only have 5 sides. Okay, of an open top box. Awesome. You guys are doing good so far. So let's scroll down. Whoop, it's a little tight there. Okay. So we have objective 3 exercise out of your ILMs. We kind of did a bunch of these, but I want you guys to make sure you know what you're doing. So I'm going to give you now until 10 o'clock to kind of quickly run through these areas on your own. So take the next 20 minutes and do objective 3 exercise. And I think that starts off on page 10 and goes to page 11. I think there's only 10, 12, let me see. There's 12 questions. So take 20 minutes, do these quick 12 questions. And if you have any questions, bring them up at 10 o'clock. So make sure you kind of try to take a break in there if you can. So the next 20 minutes, please. And I will mute the, I will shut off the recording here for a second. So I'm going to stop sharing. So I am going to do number 8 with you guys on the screen. So let me share my screen here. So as you can see, let me just zoom in here. Number 8, the answer is right there, but we'll do this question together so we can understand what it is that they were asking for. So number 8 says, how many square meters of grading are there in a 1.3 meter wide walkway around a tank with a diameter of 10 meters? So if let me grab my pen here. If I draw a 10 meter top down view, 10 meters wide, so that's 10 meters. And then I have a walkway around this, and that walkway is 1.3 meters wide. So this is 1.3 meters wide. So we want to calculate the area of the walkway. So what I have to do is now I'm just going to make this one complete circle. So this actually ends up being a complete circle with a diameter of, if this is 1.3 here, this is 1.3 here, we have a complete diameter of 12.6 meters. So we could do the area of this one first. So pi r squared. So my diameter is 12.6. So that makes my radius 6.3 meters. So I'll do the area of the big one first. That's 3.1416 multiplied by 6.3 meters squared. So that equals 124.69 meters squared for the area of the large one. And now I'm going to do the one for the inside where the diameter is equal 10. So my radius is equal to 5. So that's pi times 5 squared. And that equals 78.54 meters squared. Now I simply just have to take the 124.69 meters squared and minus off the 78.54 meters squared. So what I'm doing is I'm taking this part and I'm minusing it off of this part to get my area of my walkway. So my area of my walkway is here around the tank. This is a little catwalk, if you will, around the tank. And so I'm going to take one, minus it off the other. And that equals 46.15 meters squared is the area of the walkway around that tank. Does that help with question 8?
See, the way I read it, I assumed it was a square or rectangular grate over top of.
Sure, because when you see area, you automatically think that, right? I mean, that's normal. It's very normal to think that way. But again, we have to really disseminate the question.
I thought it was square too.
Well, it's square meters, but yeah, of course.
Well, like when you put grate in the question, I'm thinking of like anytime I'm like walking down the street, you have a rectangular grate, even if it is like that I just assumed it was just a bad assumption.
Yeah, that's okay. And that's okay to think that way sometimes, but not in this case. Okay, I'm just going to go back over. Here is the answers to those questions posted here. Does anybody else want me to go over any one of these questions?
Yeah, question 7.
Question 7. Okay. Oh, I don't want to move that. I just want to zoom in. Oh dear. Okay. Question 7. Let's look at question 7. Question 7 says, what is the area of a plate required to cover the end of a 1200 millimeter pipe? So we have a 1200 mil pipe. Ooh. Millimeter pipe. That's the diameter. So we need to cover that area. So this is simply pi r squared. That's really all it is. So if our diameter is 1200 millimeters, our radius is then 600 millimeters. Now, I asked you guys to convert everything into meters. And now I could solve the question by going 3.1416, multiplying it by 0.6 squared to get 1.131 meters squared. Sometimes the question will confuse us, Jan. Yeah, that's exactly correct. Sometimes the question will make us think something different than what it really is. Any other questions you want me to cover with you?
Do you mind if I just see the answers for 10 to 12?
You bet, sir. Oh,
Please and thank you.
just put that back. I'm moving my pages all over without not wanting to. There you go. There's 10, 11, 12.
So I don't remember if we covered this, but were you looking for a specific amount of like decimal places in our answers?
Yes and no. It's a good question, Alex. So if your answers have 3 decimal places, put it to 3 decimal places. We can round up a little bit and go to 2 decimal places. It is quite fine. You will notice that as you do some of your calculations, we're going to be pretty darn close. And pretty darn close to me is close enough when we're doing math. I'm looking more for process than I am for anything else. I know that maybe doesn't answer your question, Alex, but 2 to
No, it
3
does.
decimal places is plenty. Okay.
I just remember like back in high school, my chemistry teacher, actually all my science teachers, kind of ingrained that they wanted 3 decimal places. So I just wanted to know because like I'm getting 3 decimal places for most of my answers, but your answers have predominantly 2 decimal
2.
places. So
I
just
have
wanted to know.
predominantly 2 because if we're looking at measurements of something and we're into the thousandth of a square foot or a thousandth of a square meter, it's really quite difficult to measure anything like that. So 2 decimal places is usually the norm, but you can extend it to 3 or 4 if you want. You will
Okay, so
understand.
both are acceptable.
Okay.
Cool.
All right, everybody, that we got through perimeters and areas together. So we're halfway through this ILM already. The second half of this ILM is all about percentages and grade, which is also very important to us. Grade is super important. We want to know how to calculate it. We want to know how to do it, and percentages. Because listen, percentages also tie into grade. It also ties into our paychecks, right? How much does the government want to take from us? Most everything they want to take from me. I don't know about you guys, but I'm up over 30% in the tax bracket, so to speak, meaning the government takes more than 30% of my wages. It's just, oh, it's like a knife in the back, I tell you.
Last year, I think my percentage was like 26 or 27.
Well, the more you make, the more they take. But that's
I was opt
okay,
in for double.
because the more I make, you know what? I feel a little better.
I
But
always get them to take double off. It just makes my life so much easier.
well, and then you have to calculate it on the back end. And you know what? I'd rather the money in my pants than the government's pants. So I'll take that extra cash and I'll put it in a savings account. Now, it's important for you guys as you're going through apprenticeship is to pay yourself. And I'm not saying pay yourself as in, go buy yourself a box of beer. I'm saying take 10 to 15% of your paycheck and put it away. Put it away in a place where you don't need to take it out all the time. It's your savings, it's your future. You want to save up for the next time you go to school, right? Sure. Some kind of savings account. Yes. Tax-free savings account. Thanks for that, John. Okay. Now what I have for you guys is in D2L, I have released the next assignment. It is available for you to do. So I want you to take the rest of this class time, which is about 40 minutes, not even 30 minutes. And I want you to start the next. Yes, Kristen, that is very correct. You do get to tax deduction of your education. You get this next 30 minutes to start your new assignment, and it is due Wednesday morning. So you have to be done Wednesday morning. Taylor, I think you have 2 assignments now, including this new one. Okay, thank you. Any questions before I let you go to start working on that? Any questions
Yeah.
for me?
Yeah,
Yes.
can we look at question 3 on that assignment real quick?
Yes, sir, I can certainly do that. Let me just go back to sharing my screen. So this shows here.
Oh,
what is-
sorry, not on this one, literally on the assignment you just released.
Oh, the assignment I just released.
'Cause
Wow.
it seems to me like that's it's an impossible question with your answers there.
Okay, let me just stop sharing that for a second.
Okay.
I will pull up the assignment for you. I mean, you know, that's what I'm here for. Let me just get it here. And so. Let me share my screen again here.
Okay.
So if you pull up that assignment, you will see some formulas right on the front page. And if you want to print that off, you most certainly can. That's how the only way you're going to see that formula sheet that is on there. And let's go down to number 3. So we want the perimeter
Yeah,
of a rectangle. Yes?
yeah. There's no way you're getting 17 meters out of that though. That's your lowest answer.
How many sides?
That's 4.
Oh, I see what I did wrong there. Okay, here, before you go away, I am going to figure out something here. Hang on a second. Okay, I'm gonna stop sharing. And don't do that question yet. I'm going to fix that question.
Sounds good.
I have to go into D2L and do this, so just give me a half a second here. Okay. Okay, make it meters. Make the 8.655 into meters. Does that answer your question? Make, for number 3,
Yeah, yeah.
everybody,
That
Make-
works for me. Thank you.
make the 8.655 centimeters into 8.655 meters. I did change it in D2L. We'll see if it gets reflected in yours. Okay, anything else before I let you go to work on that assignment? No. I'm going to pause the recording.